3x, part I, we want to show that this limit as x goes to negative infinity of e to the x cosine 3x, which was our integrand from the previous problem, we want to show that limit 0. And the best way to do that is just by using the squeeze theorem. So that's what mathematical fact you're going to use. So remember, for the squeeze theorem, if you have a trig function like cosine of 3x, that has to always be in between 1 and negative 1. Because the cosine of anything can only has a range of negative 1 to 1. So if we multiply everything by e to the x, we'll get the function that we want in the center, and then we're going to squeeze it by using the limits. So if we multiply everything by e to the x, our inequality would now just look like this. And the reason we have to do this in the first place is that if we just tried to use direct substitution and just see what happened as x tended towards negative infinity, as x tends toward negative infinity, e to the x is 0, but a trig function at infinity or negative infinity does not exist, or the limit does not exist, because it's always oscillating. So if you multiply 0 by some indeterminate number, you still get an indeterminate number. So we couldn't just try x as negative infinity. So instead we have to do this squeeze theorem. Now if we do the limit as x goes to negative infinity applied to this entire inequality, if this center function is always in between these two, then when we take the limit as x goes to negative infinity of these two, it should still be in between those. That's what the squeeze theorem says. But as x goes to negative infinity, both negative e to the x and e to the x are both 0. So what we get is this limit that we were looking for must be in between 0 and 0. In other words, it's 0. So by the squeeze theorem, we have that this limit is going to be 0.